This video will be about direct and inverse variation. So direct variation uses the equation y equals kx, where k is some constant. A good example of this is when you're buying chicken per pound. The cost would be your constant. If it cost $5 per pound, then it would be $5 times however many pounds of chicken you bought. So the equation for direct variation corresponds to a graph, and the graph of direct variation is always a straight line. This straight line must go through the origin, through the center of the graph. They don't always show all four quadrants of the graph, so there's really the line still going to the left and down. Sometimes they just show this top right quadrant. If we moved the line up anywhere, this purple line is not direct variation. It must go through the center. Inverse variation is y equals k over x, where k is a constant again. A good example of inverse variation would be speed. You calculate speed by doing your distance over time. So if you drove 500 miles and clocked your time, then you could say, well, it took me 12 hours, and then calculate your speed. But then you could change the different times. Say it took you 14 hours instead. You could calculate that speed. So again, this is just a constant. The inverse variation is a curve that starts high and goes low. So an example, the amount of money Tina makes varies directly with the number of hours she works. The relationship is represented by the equation P for pay equals K times H for hours worked. If she works 30 hours and makes $600, how much would she make if she works 40 hours? So on a problem like this, they've given you the equation already, and you just need to figure out that constant using the first set of numbers given. So the pay was 600, k times the hours worked was 30. So to get k alone, we do opposite, which is to divide by 30. So 600 divided by 30 is 20. So k is 20. So now the equation is p equals 20h. Now we can take the hours she worked later, the 40 hours, and plug that in to find out her pay if she worked 40 hours. 20 times 40 is 800. The next example is for inverse variation. The time to paint a room varies inversely with the number of people painting. This is represented by the equation below. Time equals the constant divided by the number of people painting. I'm going to write it out. Usually it's right on top of each other instead of side to side. If 2 people can paint a room in 8 hours, how long will it take 3 people to paint a room? So again, we're going to take the values they give us that corresponded to 8 hours, and we're going to temporarily place them in the equation to find the constant. So it was 8 hours, k over 2 people. To get k alone this time, we have to do the opposite of division, which is to multiply. The opposites cancel. We're left with 2 times 8 is 16. So now the equation is t equals 16 over p. So now we're changing the number of people. The people will now be 3 people, so we plug in the 3 people to try and figure out the new time that it will take if we have 3 people painting. So 16 divided by 3 is 5.333. It keeps going forever. Or you could write it as the fraction 5 1/3. So next problem, the number of centimeters in a linear measurement varies directly with the number of inches in the measurement. The table below shows the relationship. So this time they didn't give an equation, they just gave some of our corresponding values. What is the equation that shows the relationship between centimeters and inches? So centimeters is our first variable. That would be the first part of our equation. We know if it varies directly direct variation was k times the next variable. So the next variable was the number of inches. So I'm going to put I for inches. So we need to figure out the actual constant to write out the entire equation. We need to take any of our corresponding sets, no matter which one we pick. If this varies directly, which they told us, then we will always get the same k. So I'm just going to pick the first set. So our centimeters was 12.7. So C is 12.7. And our inches is 5. So again, we get k alone. We divide both sides by 5. That gives us 2.54. So now our entire equation would be C equals 2.54 I. And that gives us the equation. They didn't ask us to find any of the other values, they just asked for the equation itself. And our last problem, the number of revolutions made by a tire traveling over a fixed distance varies inversely, so this time it's inverse variation, with the radius of the tire. The relationship is shown in the table below. So again, they gave us a whole bunch of corresponding values, and we want the equation. Now our two variables are revolutions and radius. We can't have both of them starting with r, so I'm going to say v for revolutions and r for radius. So v was our first variable, revolutions came first. It says it varies inversely, so we do equals and k over our next variable, r. Now we can take any of the points again. It doesn't matter which ones we choose. I'm going to choose the second set and plug it in. So revolutions was 96, v was our revolutions, and 10 inches was our radius. So to get k alone, we multiply, that's the opposite of division. So k equals 960. Now we can write out our equation. V and r will remain variables. Those can change depending on how big the radius is, determines how many revolutions, but the relationship of k, the 960, will always stay the same. So v equals 960 over r. And that gives us our equation. So that concludes our discussion on direct and inverse variation.